18th lecture of the electrostatics. In this lecture, we are going to prove the Coulomb's law by using the Gauss theorem. We have already stated the Gauss theorem and we have done the proof also. And by using the Gauss law, what the Gauss law says that total flux total is equal to Q enclosed by epsilon naught. We have to use this statement. We know that the d phi of the electric flux is given by simply the E dot ds vector, and then the flux is given by simply we have to integrate it E dot ds vector, and then through the closed surface we are interested in finding out the flux through the closed surface. Let's suppose you have the point charge. Let's suppose you have the point charge here. Then the radius, this is the Gaussian surface I have taken. Due to the point charge, there is spherical Gaussian surface, and then this area element is the direction of the area element is r cap, and we have stated here. And then the electric field and the area element both have the r cap direction. You can simply write it as integration of E magnitude, and the direction is r cap, and into ds vector, magnitude and direction is r cap only. And then you can take out the E is constant on the Gaussian surface area, and then the E come out to, and then total surface area of the sphere. And you can also write a one step instead of E r cap means the cos theta. You can put it E cross into cos theta. Cos theta is 0 degree here, and then it become E come out to be, and then integration of E dot ds vector. And then if you write the total surface, it come out to be the sphere, the surface area of the sphere is 4 pi r square, and it is nothing but is equal to phi, and the total flux from the Gauss theorem we know that is equal to q and then epsilon naught, and then E vector is come out to be 1 by 4 pi epsilon naught q by r square. And this is the electric field. We know that due to the point charge, this is the electric field. And then you can find out the force from it. Yes, force is nothing but E vector into Q. Then the force value, E vector, that's correct, yeah. Then F force is nothing but just putting the E vector value, and vector, if I representing vector, then you have to also specify the direction of the E is nothing but r cap direction. And then I have to also, then if we put the value, then we are getting Q square by r square, and this is the Coulomb's law that we have stated. And this is the simple derivation. By using the Gauss theorem, we can also prove that the Coulomb's law.